Introducing The Water Hour, the show that dives deep into the critical role of water in shaping the South African economy and society. Water supply and sewage systems in South Africa. Don't go away, we will be right back. Welcome to The Water Hour, the show that dives deep into the critical role of water in shaping our society and economy. Don't miss out on our insights and updates on water-related issues. Join us as we explore the work of the South African Water Chamber, only on The Water Hour. Welcome to The Water Hour. If you're not yet following us on social media channels, please do so. That way you'll get notified the next time we go live. I'm Bridget Limbanda from Cape Town in South Africa, and this live stream is brought to you compliments of BeLive Media, the South African Water Chamber, and StreamYard. It is an audience-centric show, so you are welcome to ask us any questions or post comments while we are live. Today, I'll be joined by Dr. Anthony Turton from the South African Water Chamber. Anthony, welcome to the show.
Good afternoon to you and the listeners.
Good to have you join us. We are, for want of a better word, have entered very interesting times in South Africa. So I'm going to start off by asking you how you would describe the current state of power outages and its effects on the water supply and sewage systems in South Africa.
Okay, Brigitte, we're getting into an enormously complex area here. And the reason why I say it's complex is because we can't predict exactly what's going to happen. So let's start using a couple of sort of analogies just to try and help people to get their heads around it. We've come from a lifetime where we've accepted certain realities, and our entire frame of reference is based on those realities. And the two realities that we've accepted as normal is a stable electricity supply and the water services that are engineered to what is known as a 98% assurance of supply level. Now, that's an important thing that most people don't know about, because the 98% assurance of supply means that all systems are designed to allow for one breakdown in 50 years, two breakdowns in 100 years, two breakdowns out of 100, or one breakdown in 50 years. And therefore, we've accepted that as the norm. And therefore, maybe in a lifetime, a person will experience a breakdown, maybe in a lifetime. And maybe they will be short, sharp, and rapidly fixed up. So we're now going into a situation where the same with the energy side. I don't know what the exact design level is, but it's probably more than 98% assurance of supply. So in other words, the entire assumption on which our economy has been based are these assurance of supply levels. Therefore, everything in our economy is simply hard connected with pipes or pumps or wires or cables or whatever onto those two simple truths. So now we are going into a new future. We are crossing what I call a threshold of concern. And that threshold, as you approach a threshold, think of a black hole in outer space, in the universe. You're approaching a black hole, and you get what's known as an event horizon around the black hole. And once you approach the event horizon, the gravitational pull inside the black hole exceeds the amount of energy you can ever use to get yourself out of the black hole. So we are approaching this event horizon now in South Africa, where we just don't know what's on the other side. We honestly just don't know. So we can speculate, and we can use the most sensible logic. We can use fundamental principles of science and engineering, and we can start, getting our way around it. But basically, this is where we are today. So we have completely discarded the 98% assurance of supply system for water, and the energy system is unstable, unreliable, unpredictable, and in the process of failing in different parts. So that's our new reality. So now we have to start looking at this, and depending on who you are now, who you are depends on the questions you're going to ask, and depends on the impact that you're going to experience. So if you are, for example, a factory that manufactures a critically important good, let's just say that you're a factory that crushes maize, and you're the only maize crushing factory in the country. Well, if you don't have energy, you can't crush maize. Therefore, the implication of that now becomes national food security as a problem. But if your company is about transporting goods that are frozen, and then the cold chain breaks down, there's another set of consequences that cascade out into society. If you're just an ordinary person at home and you don't have bath water today, well, you're not going to wash your hair today, and you might not smell as good as you would like to, but you got to get through the day. You got to find another way to flush the toilet. So it depends on who you are as to what questions you need to ask. And this is part of the complexity, because it's not one question for everybody in society. And the consulting work that I'm doing at the moment now for corporations is dealing with just this matter. I'm helping them to map out in their own reality what their future implications are, because they don't even have a frame of reference, having never lived through this before. They don't have a frame of reference to say, so, well, what is likely to happen?
Could you outline some of the challenges that we face with the extended power outages that we have on our water reservoir, and the ability to provide water supply?
Yes, okay. I'm going to start off by giving you a number just to help the listeners now sort of contextualize it. Now, this number is possibly contestable, but it's a number I'm going to give you. So I recently read a report that was published that was actually funded by USAID, and it sought to benchmark the amount of electricity in a society that goes to the water sector. And the report gave quite a big number. It gave 20%. It gave 20%, plus minus 20% of the water 20% of the energy in a given area of the country, say in a municipality, is allocated to water. Now, I spoke recently to Benoit, and he said that in his experience, it's closer to 10%. So let's say in a range from 10 to 20%. That's one tenth of the energy in the country that goes to simply moving water around. So that's it. So just think about that. So 1/10, between 1/10 and 1/20 of all of the water in the country, all the energy in the country goes to moving water around. And a significant portion of that is the treatment of waste, because wastewater is very energy intensive. We've got to do lots of things. So let's break it down now. So the first thing that people need to understand is that water has got a long and complex value chain. So let's start off with it. All water comes from rainfall somewhere. It then ends up in a river. That river then typically ends up in a dam, from which water is abstracted into a bulk water treatment plant, where Hamad Kassan comes from, the Rand Water bulk water treatment plant. They process and treat the water. They then store it in some off-channel storage facility, and they then pump it over vast distances, hundreds of kilometers of really, very large pipelines, 1.5, 2 meter diameter pipelines, that they then pump it into very, very distant municipalities, where it gets delivered through a meter, where the meter now measures how much is sold to the municipality, and the municipality receives that water, and they then have to store it in a range of reservoirs. There's not just one, there's a whole barrage of them, a battery of these things. And then they have to move water around their internal network using pumps and typically going up into high water towers, because that's what gives the pressure. And then ultimately they reticulate it out into society. And then the reverse happens. The water gets collected at the wastewater system, and it all flows by gravity now, but there are sometimes pumps, then flows into a wastewater treatment works where it gets treated and put back into the river. So there's that circular process. Now, in every step of that process, energy is required, in every single step. So if you take, for example, Gauteng province, by virtue of its high altitude above sea level, it's 5,000 meters above sea level. So half a kilometer above sea level, the water's got to be pumped over the Drakensberg Mountains, which is higher than that, and it's got to be moved around vast quantities. And you've then got to pump it through all these different treatment processes. Every pump has got to be powered. Every turbulator, every pressure vessel. There's all sorts of things that happen in the process that have to be powered by energy. So when you don't have a supply of energy, or a stable supply of energy, you start getting a myriad of effects. It's like a spider web of effects that come out of each of those incidents. And those spider webs start basically intersecting and overlapping. And that's where the unpredictability comes from. So, for example, you asked the question now about your reservoirs in a city. A typical city, the design parameters would be, firstly, I explained 98% assurance of supply. So therefore, the assumption is that you're going to have one breakdown in 50 years. Then the second assumption will be whatever your population is, multiplied by their daily consumption, their average daily consumption, multiplied by 2 days. It's 48 hours of backup. That's what you will typically have in your system. So it's a very simple calculation. It's actually quite complex, but it's at a simple level there. That's what it is. But that's what you've got as your strategic backup. Now let's start looking at changes to those parameters. So the first change we already know is that we don't actually know how many people there are in the city anymore because of uncontrolled migration of people, etc. So the demand for water is way, 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 way up. So they don't actually know how many people that they're supplying. That's the first thing. Then the second thing now is that the system's leaking like a sieve. About 40% of the water, up to maybe in some places 50, even 60% of the water, depending on where you are, gets lost in the system. Then you've got what used to be 48 hours worth of backup storage, which is now no longer 48 hours because of all the things I've explained to you. And now suddenly your pumps can't work to fill it up because your electricity is broken down. So then you start seeing localized failure, like a sort of rippling out from the center, like shock waves that go from the center, and your high-lying houses or your high-lying units, whatever, your factories, whatever, they're the first to lose their pressure, and then eventually it trickles down to the lowest lying units are the last to get water. And that can last for anything from 24 hours up to a few weeks. Here in KZN, we have outages for literally a few weeks, even a few months at a time. So it's a serious matter, and in fact, no modern economy is capable of functioning like that. So we've managed to survive up to now because the breakdowns have been patchwork breakdowns in different parts of the country. So there's been a kind of resilience built into the economy because if one little part breaks down, at least another part of the country is working. Now we're starting to go to a national grid shutdown situation where the entire country breaks down. So now we're going into completely unknown terrain, and we can unpack the logic of what's likely to happen there. We're not sure what's going to happen, but we know the most probable things that are going to happen. We can unpack that. But that explains why that 48 hours of strategic storage is so important. But we don't have 48 hours anymore because we got more people than we should, than the infrastructure is capable of sustaining. Plus, the infrastructure is degraded, so we're losing it faster than we can pump it in. Plus, we don't have enough energy to keep it full in the first place. So that's one layer after another. So basically, it's a whammy. It's a triple whammy, and it's almost an unsurvivable thing. I don't want to preach doom and gloom, but these things are seriously catastrophic in their outcome. The consequences of this are very, very serious. It's not just a trivial matter. This is a very serious matter indeed.
So, just in layman's terms, a lot of things that were built years ago were a bit more sturdy than what one generally gets today. The older pumps, you know, what is their resilience to load shedding? Obviously, they were not designed to have these sudden power disruptions. You know, how long can they survive these constant power interruptions?
Okay, so you've got a couple of things we need to separate there. So let's just look at, so in a pump, you've got an electrical side to a pump, and then you've got a hydraulic side. So you've got a water side, no, then you got the electrical side, and that's a nice way to start thinking about the whole national economy, because the national economy also has an electric side and a water side. So at different levels in the economy, we've got these water and electric things that come together. Now, when we're turning things on and off, how do they turn a piece of the grid on and off? Let's first ask that question so that the listener can understand that now. So let's once again go into fundamental design, engineering design. So the way the grid is made of a centralized supply system of high voltage, high tension lines, into which we have all the other feeder lines coming in. So from all the different power stations, they feed into that. They've got to synchronize. They've all got to be at 50 hertz, exactly the same frequency, or else they clash with each other. They then get distributed at very, very high voltage, and they then go through switching stations. And these are high voltage switching stations, very high voltage. Many thousands of volts worth of switches that are up there. And then these things cascade out eventually from higher voltage to lower and lower voltage until they eventually come down to the kind of domestic level where in a suburb, your electricity is delivered at 380 volts, from 63,000 volts, maybe even more. It's stepped all the way down. So every one of these step down processes is a transformer. And a transformer is a transfer of energy from one voltage to another, from one high voltage to low voltage. But it's a transfer of energy. It's a machine that transfers energy. That's what it does. That's what a transformer does. Okay, but now it is protected by switchgear. So these are switches that open and close. They open and close. But now you got 63,000 volts as they come together, and this thing starts arcing. You get an arc here. You get like a welding arc, jumps across it, and it jumps across. And those switches have got a defined life cycle. Because each time you open and close them, the spark they create consumes a portion of that electrode. The electrode gives up a piece of its mass. So you can't open and close it indefinitely. It's not a light switch at home. Even a light switch has got a finite life, but a light switch is designed to be turned on and off multiple times a day. But these high voltage switchgear things are not designed to be turned on and off every day. So the first problem we have now is that we are using high voltage switchgear in a role that it's not designed to be used in. Therefore, we're now starting to get the high voltage switchgears are now reaching the end of their life, and they are fading. They're becoming dysfunctional. That's the first problem we need to understand. The second problem now is I've explained that these transformers are they transfer energy, but big energy, serious energy. Now, these things have got all kinds of important things that happen inside that transformer. The one thing is there's a heat buildup. Because energy transfers heat, there's inefficiencies, there's resistances, etc. So there's heat. So there's all sorts of cooling systems on these things. And part of the cooling system is think of a radiator on a car, where you put water in the radiator and that cools your engine down. Well, transformers have got the same thing. You'll see there's a radiator on the side of a transformer, but there they've got oil. They've got transformer oil. Now that has also not been maintained, because remember, in the transfer of energy, you've got electrons that are transferring each other through magnetic fields, and these things also start eroding away little atoms and whatever. You start getting a migration of material over time, and that saturates the oil, and the oil starts to become conductive. From being non-conductive, the oil starts to become conductive, and it then starts, when it conducts now, it short circuits the whole thing, and you get these spectacular transformer fires. Now you've seen, I'm sure every citizen in South Africa has seen images from WhatsApp of these spectacular transformer fires at some place or other. Now that's the lack of maintenance. That's the oil that's become conductive. People just simply haven't changed the oil. They haven't looked after the very basic maintenance. They've overheated or whatever, and these things suddenly explode. So by opening and closing these things too often, firstly, the switchgear wears out. But secondly, now by putting a big bang into the system and then taking the bang out again and putting another bang, think of each time you turn on and off at such high voltage, you pulsing a massive amount of energy into a machine that transfers energy. So you are throwing a big iron ball around. Just think of a weight that you're tossing around inside something in an uncontrolled way, and you're causing damage within the system. So that's the easiest way to think about it. Now, if you go down to from the transformer level down to the ordinary the level of the pump, the swimming pool pump, or it could be the big pumps in Rand Water. Rand Water pumps are 11 kV pumps. So the motors are driven by 11,000 volts of electricity. 11 kV. That's a typical pump, and it's not measured in watts. Or in kilowatts, it's measured in megawatts. Okay, so you get a fraction of a megawatt, or 250 kilowatts, or whatever. But these are big motors. They're the size of a motor car or a minibus taxi. That's a small motor. A small pump motor is the size of a minibus taxi, and it's driven by 11,000 volts. So all of this has got sophisticated control gear, etc. And it's not always designed, because there's got to be an operating temperature. It's got to run up to an optimum temperature. Now you're shutting it down for a while, so it cools down. Then you're suddenly putting a big high energy surge through it, but it hasn't warmed up yet properly. So you've got all of these extreme things that are happening now in the system. And then, of course, on the hydraulic side, now the transfer of energy from the electrical coil in the motor, that now gets transferred into the fluid by means of an impeller. Now that impeller also is doing funny things. It's spinning at different speeds. It's cavitating. Cavitation is what happens when you get little air bubbles on the impeller. Remember, across an impeller, I'll just explain to the listener. An impeller is a fan-like sort of shaped structure. Think of a ship's propeller. A ship's propeller is an example of an impeller. So that you got the different angled faces on the impeller, and those angled faces are moving at very high speed, 1,000 revolutions per minute. So it's quite a high speed. It could be even higher than that. And across the length of each of those blades, you go from a low pressure in the center to a very high pressure on the outside. So there's a pressure gradient across each blade on an impeller. And once you go from a low pressure to a high pressure, and you've got air in the system, your pockets of air expand and contract. Remember, water can't be compressed. If you compress water, you don't get less water by compressing it. The volume stays reasonably constant. But air you can compress. So it's the compression ratio of water and air that now causes all kinds of dramas. So you've now got this low pressure center, and you've got a little bit of air in the system, and you've got this very high pressure outer periphery on the pump, 11,000 volts of energy going into this thing and pumping very high pressure stuff. And all of a sudden you get cavitation across that impeller. And cavitation are these bubbles that flash from tiny little micro bubbles. They flash into sort of suitcase sized bubbles. And then they suddenly collapse back down into tiny bubbles again. And it's that rapid expansion and contraction over the length of the impeller that the way I learned about it, the person that taught me said it's like having hammers, someone with thousands of hammers, knocking the hammer against these impellers over time. So you start getting a degradation of the efficiency of these systems over time. And yes, they're designed to handle this kind of thing, but not the abuse that we're throwing at it now. So these are enormously complex engineering issues that we are now fiddling with, or we are inducing failure. We are reducing the useful life of machinery simply because we are abusing it. We're running it out of the range of specification for that machine.
Anthony, what are some of the immediate and long-term consequences of the ongoing power outages on water availability, not just drinking water and water for everyday use, but also the functionality of sewage treatment plants. Now, we are currently facing an increasing possibility of grid failure, or at least having 16 hours a to citizens in terms of water supply and sewage.
Yes. Okay. Now, so there are a couple of things that you've said there. Now, so let's try and find a point of departure. So the first point of departure is that when we're talking about risk, and I spoke earlier on about this threshold event, this threshold of concern. At what point in time, at what line, when we reach that line, when should we be concerned when we're approaching that line and going over that line? What's going to happen on the other side of that line, and what should we be concerned about? Think of that event horizon around the black hole now. Now, that's relevant in this conversation now. So sorry, I've just lost my train of thought here now. So yeah, I've lost my train of thought.
Now, we were just talking about, if we do have these extended outages of 16 hours or grid failure.
Yes. Okay. So now the question is, where is that event horizon? I mentioned earlier on that we're going from a situation of great certainty to a situation of uncertainty. So at what point in time do we transition from knowing to not knowing? And there's a lot of conversation amongst professional people about this. And I know that speaking on the Water Hour with the chamber members, Fred and the rest of Benoit, what have you, they talk about stage 8 as being sort of unsurvivable. Yeah. I've heard of other people talking about stage 6. So we don't yet know. We don't know firmly, is it stage 6 or is it stage 8? But somewhere between stage 6 and stage 8, it starts becoming unsurvivable. And okay, so what do we mean by that? Now, so let's just say on average, okay, let's call it stage 7, but we don't, that's not a firm number. We can't say definitely for that. But just say somewhere between stage 6 and stage 8, it starts becoming unsurvivable. Now, why is this so? So the easiest thing that the average person would be able to grasp on, through their own experience, is that almost everybody in South Africa has probably got some automatic gate opening device somewhere in their life, a garage opener or something like that. Almost everybody. So almost everybody, I will also be fairly confident, has experienced the problem where at stage 2, stage 3 load shedding, their gate opener still works. But when they suddenly get to a certain point, stage 4 or whatever, stage 5, suddenly the gate opener stops working. Okay, now why is that so? Why is that? So what's happened to the gate opener is exactly the same as what happens in the water system. Identical thing. So in the case of the gate opener, you've got a storage capacity in the battery, and that battery has to be charged. Let's just say it's charged for 6 hours, and then it can run for however many hours it can run thereafter. So if you don't put your full 6 hours of charge into it, but you're taking energy out to open and close the gate, guess what? The two curves cross over. You haven't got enough energy, and the battery in the system falls over. Now exactly the same thing happens in your reservoirs. Exactly the same, but now it's not electricity. Now it's water that we're storing. But exactly the same principle. So in other words, there's a finite a moment in time when you transition from okay, my system can cope. My battery backup on my garage door opener. You find at that moment, the previous generation that didn't have battery backups, they would suddenly now all go and buy battery backups. So people spend money, and all of a sudden now people upgrade their system to have a battery backup. And they're all very happy. They think they've solved the problem now. And that goes until you get another level of load shedding. The other level of load shedding, suddenly the battery backup doesn't work now. So now what do you do? Okay. But now it's funny, you don't hear people complaining anymore about that. You heard them complaining when it was starting to happen, but you don't hear them complaining now. Why is that? The lesson to be learned is people have adapted. They've adapted accordingly. Humans have adapted. They were 100% reliant on the machinery. Now they're no longer 100%, so they've made another plan. They've either got a bypass, or they put in a bigger battery, or they've done something else, or they just simply have gone to manual override, and they just open and close the door by hand. But that's what's happened. So the lesson there in that everyday life experience of a person opening and closing an automatic garage door is exactly what's going to happen now in society with water. People are going to adapt. So you're going to get a generator, they're going to get a whatever, they're going to build a tank in their system, they're going to store their own water, whatever, they're going to have jerry cans in the kitchen, they're going to do something, but they're going to adapt. Now the question is, when we go over those thresholds, how sustainable is that, and what is the impact on the broader society? So we, the individual, have survived, and I'll give you another example. I'm sure your eyes will light up when I give you this example. When we first started doing these live stream events, we were very frustrated when there was load shedding somewhere in the system because the internet network became unstable. Am I correct? So it was quite common that you suddenly get all kinds of funny things happening because your system stability was affected. So I'm going to ask you a question now. Is the system stability better today than it was, let's say, 6 months ago? Yes or no?
Yes, it is.
Based on your experience, it's better today.
It is. Based on my own experience.
Okay. So now let's unpack what you just said, because I fully agree with you. Because what you've described now is exactly what's happening in the economy. So yes, the system stability today is better than it was. I'm talking about internet now. Internet system stability is better today than it was 6 months ago, even though we've got more load shedding now than we had back then. Why is that so? And that is so because human ingenuity has intervened and we have put in redundant systems. So your service providers, they have put in bigger generators or bigger batteries, or they've gone to from copper to whatever, but they've done something. They put solar, whatever, but they've done something. So we have made our systems more resilient by taking ownership back of that, and that's an important lesson. Or you can almost say that's the sort of silver lining to this very, very dark cloud that's hanging over our head at the moment. Factories are starting to take control. Companies, building owners, people, households are starting to take control, and they're starting to adapt. So yes, while it's a very, very depressing and gloomy thing, ultimately it's also making us tougher. It's making us more resilient. It's making us take ownership back from the state, because we outsourced. In my lifetime, we've outsourced all of those things. From when I was a kid, we used to manage our own water on site. We had our own borehole. We had our own stuff. And then we outsourced that now to a clever government. Now the government's not so clever anymore. So now we are taking back. We're taking ownership of that back. And that's how they're going to be our future. So I was recently at an event where people were talking about privatization by stealth. So privatization by stealth is what is happening in the energy space and also going to be happening in the water space, where if government cannot provide, then simply someone's going to make a plan and they're just going to do their own thing. So a shopping complex, a retail shopping complex will go completely off grid because it's a little unit that they can manage, and that's it. Now, is that legal? Well, that's another matter. You kick that can down the road, because, if they can't supply electricity today, well, then the regulator can't breathe down your neck either. So it's only when the electricity supply comes back and stable again that we'll deal with the regulators sometime in the future. And at that point in time, you're so off the grid, you're so independent, you don't need them anyhow. So I think that's going to happen in the water sector now as well. So we've got to start thinking about these things. The way I describe it to my clients when I'm working with their risk assessments, I try and explain, just to get these sort of mental maps in their mind. I try and describe as spider web. These orb spiders. You get a spider web with these circles. These circles, small circles, bigger circles on the spider web, and then these radials. All these radials that go out from the center out. And then what happens is, from those radials, you get this intersection now between the one concentric circle, and all of those radials. Now, each of those circles is one of these thresholds of concern I'm talking about. That's a threshold event, where we're going from where we know what we know today. Now we are going out ever distant along a given radial. Our little radial is the one line we're going out on, and we are exploring along that, the intersection with the next event horizon, and the next one, and the next one. And each time we're learning and we're adapting as we go along, and it's frightening at first, and then eventually you get used to it. You get used to it. You just adapt and you just deal with it, and it happens. So you don't shower today, so you shower tomorrow. So just change your behavior, and that's it. Use more deodorant. Just that's the way of the world. So the question now is, can the economy survive that? That's the big question. So we start asking a whole lot of different kinds of questions now. So in working with my commercial clients, the one question I ask them now is, can your factory survive this? How long can your factory survive with an energy outage, or how long can your factory survive with a water outage? And then you've got to start, once you know that number, once you know that particular number, you can now start saying, well, what do I need to do to basically build backup for that period of time? Then you've got to ask another question now. So if I need that size backup, what is the cost of that backup? And then what's that going to do to the cost of my product that I'm producing? Will my product still be competitive in a competitive market? And if not, then you're going out of business. If not, you're finished, you're gone out of business, in which case your logical decision is shut the business down. Logical decision. Just, cut your losses, because you're going to throw money down this bottomless pit, and from thereafter, you're just going to bankrupt yourself in this process. So a completely rational decision is recognizing that the cost of sustaining this thing in a competitive market where you've lost your competitive advantage is no longer viable, so your business is no longer viable. Now, there are a whole lot of things you can do around that, but you get another partner in, you recapitalize somebody else, I don't know, there's 1,000 things you can do, but you've got to understand that that's a threshold. You had a threshold point now, beyond which you've got to navigate yourself along that radial over that threshold to the next unknown state. So I'm speaking as if it's a very clinical thing, because in my world, I have to think clinically, and I have to think abstractly, and I have to help clients to understand these complex things and to come up with real concrete, real solutions to these things. So the good news is they are soluble. These things are soluble. And in fact, the really, really good news, we've had it now from the internet experience, we actually come out better. We've probably got a better internet now than we had 6 months ago, despite the fact that our energy supplies got worse. So in other words, we've adapted accordingly, and that's a good thing to be in. It's a good place to be in, because we are becoming less dependent on a government that seems to be less and less competent and less capable of dealing with our very, very real needs, in the priority that we think they should be dealt with. So increasingly, we're getting government coming out of sync with the needs of society. So there's this increased slow alienation process. Government becomes more and more irrelevant over time as they are unable to solve these problems and come up with these weird, outlandish things about the coal, whatever transition, and Gwede Mantashe sitting saying, no, you can't change this, and wind, it won't work. And all of these are vested interests. So they just become irrelevant. They just become noise in the system. And society just moves around it. They don't even get involved in the conversation. They just move around it, and they just solve it, and then you carry on with your little fight over there. And we've got a new system. We've got a new, our shopping complex or our factory or whatever is now up on wind or solar or whatever it is, and we don't care about the Eskom anymore.
So what is it that we as citizens can do to prepare ourselves for in the event of grid failure? What can we do to prepare ourselves for that as citizens and businesses?
Okay, so let's unpack that now. So firstly, grid failure as a grid, I've heard from very smart people is not likely. And the reason it's not likely is the grid is designed to shut down incrementally. So the possibility of having total grid collapse is relatively remote. It's not impossible, but how do we quantify it? Let's say there's a 5% chance of a total grid failure, 5% chance. But before we get to that point, there are tripwires. The same story, the same radials, the same circles on the spider web. As you go from the middle, you cross all these intersection points. The grid is designed in the same way. It's designed to trip out in blocks. So that's what load shedding is about. Load shedding trips out certain blocks in order to make sure that there is no grid collapse. So grid collapse only happens when load shedding no longer works. Now that's a bad place to be. So having said that, when we go further down the line, people are talking now about stage 10s and what have you. Now we spoke earlier on in this interview about is it stage 6 or stage 8? Which of the two is the threshold to an unsurvivability situation? Well, we don't know. So let's just say for argument's sake, it's a stage 8. So what is the probability of us going beyond a stage 8 in the current winter season we're in now? And I would think we've got a better than 50% probability of going into beyond a stage 8. So we don't know what is it a 60, 70, 80%? We don't know that, but it's better than 50. So in other words, on a 50-50 thing, we flip a coin. In all probability, we're going to go into a situation where we exceed stage 8 load shedding in the coming winter. So fine. If that's the case now, that means we got 12 more than 12 hours a day of no energy in the system, in your local system. But that doesn't mean to say there's no energy in the national system. It's just that it's in your local system you don't have it. And the same with water. The same will happen with water. In your local system you won't have it. So now, what does that mean? It doesn't mean that there's no energy. It just means that you are going to experience the blackout, and that's going to protect the integrity of the grid itself. But it could be off for 48 hours. It could be off for a week. It could be off for a month. You don't know. So because you don't know how long it's going to be off for, I think this is what people should start planning for now. Now we get into the real nitty-gritty of what people can really do. So I think the first thing that people must do is they mustn't panic. Mustn't panic. I mean, I've said some hairy things now, and that sounds all horrible, etc. But don't panic, because the good news is we've managed to build resilience in our own lives. So step number 1 is don't panic. I think step number 2, dare to try and imagine life without water and electricity. Go on an imaginary journey. Just imagine the future that you're going to live in. And that process of imagining is very, very important, because it's an intellectual journey. It's a mental journey, and it's not a frivolous affair. There's this famous physicist, Professor Stephen Hawking. Stephen Hawking. He had muscular sclerosis, and he was in a wheelchair. And he was a quantum physicist, and he's the guy that he said, because I can't move my body, I'm going to go on an imagination. I'm going to use my imagination to take me on a journey. And he went on a journey into a black hole. He said, I'm now a little particle of light or a particle of substance, and I'm moving through this black hole. And he applies all the laws of chemistry and physics as he goes through there, and he then develops this whole new model of quantum physics. So humans can do that. We can do that. We can just imagine, just make a little family fun thing out of it. Okay, around the dinner table, start asking what's the most outlandish off the wall you can think of if we have no electricity for a week or no water for a week. And by asking those questions, you start harvesting those answers and write them down. And you'll be very surprised that you start actually, the more weird and wonderful you think, the greater you get close to the reality of what you're going to experience. So you think out of the box, be outlandish. The process of imagining must know no limits. You want to be as wacky as you can. The wackier, the better. Now, once you've got those things down, now you suddenly start getting insight. And in my professional opinion, one of the first thresholds, mothers particularly, mothers go into panic mode when they can't flush the toilet. So the first problem is you can't flush the toilet. What now? Crisis. So adapt your behavior. And the easiest way to adapt behavior is have a bucket of water in the bathroom next to the toilet, and you fill that bucket of water from any one of a number of places. Fill it from your swimming pool if you've got a swimming pool. Fill it from your bath. So don't let your bath drain out. Keep some of the bath water for flushing toilets. Fill it in a 25-liter jerry can if you must. Okay, but just fill it in some way. Just have an alternative supply of water, and then you simply use it each time you flush the toilet, and bingo, you've solved that immediate pressing problem. And then you start adapting according to this roadmap in your head. But the important thing is that journey, that intellectual journey, that mental journey, it starts building fortitude in your heart, because when you encounter each of these things now, it's no longer a shock. because your outlandish after dinner conversation has now taken you to these weird and wonderful places. So suddenly it's not so shocking to think about these realities. And that's what builds the knowledge base of what we need to do. And ultimately it comes down to the fact that we've got to start thinking about a disruption of supply of both water and electricity, but particularly water. In our case, this is the water hour. So we've got to think about the disruption of supply in an extended period of time, or over an extended period of time. And we've got to think about three specific kinds of disruption to the power. So let's just quickly unpack what those three things are. The first disruption to water is the total catastrophic loss of all water. You've got no water at all. So what does that mean for your own individual life? How are you going to manage that? And you work out your little map of how you're going to do that. The second thing that is the most likely that's going to happen is you're going to have a loss of pressure. So the first thing that happens when you don't have enough water, so you've got some water, but you don't have a high pressure. The flow is very low and you don't have enough pressure behind the system. And immediately this manifests in the household with your white goods, your washing machines and your appliances. Appliances all need a certain pressure to function. If you go below the certain threshold of their little threshold value, if you go below that, then they are unable to function. So then you're going to have to start washing dishes by hand because your automatic dishwasher won't work, or you're going to start washing clothes by hand. And that's going to change your lifestyle in one way and adapt accordingly to do whatever it is that you have to do there. And then, of course, the third thing, this is the insidious part, is a loss of water quality, a loss of trust in the water quality, or an actual loss of water quality, where you may be starting to get bacteria, or you're starting to get pathogens, or you're starting to get toxins in the water because the system is broken down. So the treatment plants are no longer functioning. And I think the biggest thing there is the psychological loss of trust, loss of confidence. Because if you don't trust it, if you don't have confidence in it, then that starts playing mind games in your own head. And you've got to manage that. So you got to manage that in a way, in your own way. So you've either got to disinfect water, that you keep in your own household. And jig, for example, works wonders. If you've got electricity, boil it. If you haven't got electricity, get gas and boil water. If you must, at least to prepare food. So there are different adaptive strategies. But just the important thing is, understanding the sort of framework that I've laid out now, very, very sort of basic framework, but everything that you're going to encounter is going to fit into different elements of that framework. And the important thing to anticipate is that as we cross over these thresholds, let's call it a stage 8 as just as a broad ballpark number. Beyond stage 8, we're going to get into a completely different scenario, like your automatic gate openers or your automatic garage doors. Suddenly your batteries aren't going to work, and you're going to suddenly realize it, and then you're going to panic for a while, and then you're going to figure it out and you're going to do something about it. So that's likely to happen in the very near future. And then just think about the total loss of water, the loss of pressure, and then think about the loss of water quality. So each of those things have got different strategies, different solutions that you have to have, and then ultimately start thinking about some kind of storage that you control, storage where you are, so on-site storage in your house. So either 1,000-liter JoJo tank outside, or you have buckets or something like that. But remember that secondary contamination. The literature is quite unanimous on this. Water tends to be contaminated in these secondary storage vessels. So where you got a bucket or something like that, that's where you're likely to get your contamination. So even if your incoming water is clean, just be careful that your storage facilities, your storage containers, do not get contaminated. And that's about it. And if you're running a business, if you're running depends what your business is. So you've got to think this thing through. I was working just last few days with a company that's in the mine services industry, and they wanted to understand what the impact is to their business. And but there's not a direct impact. Theirs is mostly about staff and staff hygiene and stuff like that. So it's quite easy to deal with. But there are other implications about. So if there's no water in the mines that you're providing your services to, is that mine capable of continuing its operation over time, and therefore will you have a business a year from now? That's entirely another matter. So you've got to think these outrageous things about, what happens if there's a total collapse, and what happens if my customers can't pay me, and what happens to my business, what happens to my livelihood, have I got enough savings? All those, we go into the deep, dark, murky parts of our mind now, and now we can start going to the very, very primordial fears that can grip society, and we want to get away from that by introducing this logical, psychologically robust, technically viable sort of framework.
Now, we've spoken about almost sort of worst case scenarios here. Are there any opportunities for entrepreneurs and manufacturers to explore renewable power solutions, and also ways in which they can use water more efficiently to keep business functioning as we move to possibly stage 8 and beyond?
I think the simple answer to that is yes. Absolutely, it's possible. I've just recently been working with a very, very large company. They have a number of manufacturing units, so it's a company that manufactures stuff. And I asked them what is their consumption per manufacturing unit of water, and how is it allocated over hygiene and processed water and whatever else, water that becomes product. And they didn't have the answer. They don't have the answer. They just don't have the answer. So you're going to start finding now that this crisis is going to start bringing about new solutions. And so that's where the entrepreneurial opportunity lies. So if you look, for example, at artificial intelligence, AI, as an opportunity, a huge opportunity, where this crisis is now going to cause people to start to rethink their whole supply chain, their whole value system, etc. And therefore, your instrumentation about how to measure pressures and flows and whatever, what does that mean? How can you improve the efficiency of that? And that's what Fred and Benoit, they are deeply into that space. In fact, my own company as well is also quite deeply into that space. So that is likely.
You need to think about the numbers, really.
Yeah, because once you know the number, then you can act on it. So in the case of this client I'm working with at the moment now, it's a listed company. They're listed on the stock exchange, but they can't give an accurate figure across all of their production units. They don't know. They simply don't know, because they've simply accepted up to now that it's 98% assurance of supply issue. So they are busy mining those numbers out. They're going to dig them out of the system somewhere. And then, so that's the first step in the process. And eventually they will probably upgrade to some AI platform, where these things are captured in real time, and that can start predicting the future for you. But this is the start of a journey to a new place. And I think that's the important thing now, is that while there's going to be a crash and burn for some in this very gloomy scenario, it's not going to be crash and burn for the whole of society everywhere. So the first step is you must make sure that you are in the part of society that doesn't get obliterated. Your own short-term survivability, that's important. You must survive. But then the second thing now is that's going to simply rearrange society. It's going to rearrange society. And if I can sort of polish my marble ball and sort of look into, gaze into the crystal ball, I think it's going to make government less relevant in the future than they've been in the past. So I think it's going to start cutting dependency between people and government, which means you're going to get a big fight back from government, because they don't like that. They want you to be dependent on them. So there's going to be that's going to be quite a brutal battle, but that's going to be happening out there, in the bleachers. That's going to take place. And then, of course, there are new technologies and new processes. And the other thing that's going to happen in a brutal way, absolutely brutal way, is that if you're running a little business from home, or you're running a whatever little manufacturer, whatever it is, whatever your business is, if you are in a competitive market where the goods and services that you are producing are also produced by others, and those others might not have the same challenges that you have, then these crises are going to potentially knock you out of the market. They're going to destroy your business. Now, this is a serious matter. So the seriousness of this matter is going to cause those entrepreneurs to rethink their business and to streamline and to improve wherever they can, to dig deep and figure out where they can make differences and improvements. And they're going to come out of this either as shut down, completely dead, flat line, or they're going to come out of this thing stronger than they were before. But the important thing is they're going to go through that threshold. And ultimately, if you extrapolate that up across society, I think you're going to find that the manufacturing sector in South Africa is going to take a huge hit. Our GDP from the manufacturing sector is going to probably be quite severely affected. But you're going to find now, if you cascade that logic, that I'm going on one of those little radials, and now in my spider web, I'm going along that radial now. So this is the investor radial that I'm on now. So as your investors start looking at this problem, they're going to start saying, whoa, so is this problem an existential threat? Yes or no? Is it going to wipe the business out? Yes or no? Do I disinvest from the company? Do I sell my shares, or do I retain my shares? So there's that level of sort of thinking already happening. We've probably already gone past that now. They're probably, people have made those decisions. If they want to sell their shares in South African companies or whatever, that's already happened in all probability. So now the next thing is, okay, so therefore we're going to stick it out. We're going to stay here. Therefore, what do we need to do next? And now you're going to start getting this rational process of comparative advantage and improvement of efficiencies. And ultimately, it's going to make society more robust. But as I said, it's going to make, in my opinion, it's going to make government less relevant. We're going to become more independent of government, and government's going to become just more their presence will be felt more as a hindrance or a stumbling block rather than as an enabling force. And you will see this now where your energy and water solutions start coming in that are not necessarily fully regulated. And it's my understanding that the energy space, the regulators kind of like almost got hands off now. They say, if you can bring capacity into the grid, do it. It's a free for all. Now it's not going to last like that forever. It won't last like that forever. But the people, the first movers, the fast movers, they're going to move in. They're going to take advantage, and they're going to suddenly, become the sort of market leader in that particular segment. And that's great. You're going to get a couple of oligarchs are going to be made out of that process, because that's what happens in these crises. In socialist countries, oligarchs make money out of it. So that's going to happen. But then at the household level, once again, we cascade down to the household level always. The household's got to feel that. They're going to feel that in a different way to what your corporates are going to feel.
Absolutely. Anthony, thank you so much for your time and explaining all these nuances in layman's terms, because I think it's very important for the public to be able to understand, and that we don't always talk over their heads. So thanks for breaking down the situation, and always appreciate that you're very honest about what people can expect to happen to the best of your ability. So thank you for that. A huge thanks to our listeners for joining us today, and I hope you enjoyed the conversation as much as I did. And we'll see you back next time on the next episode of the Water Hour. Thanks very much, everyone. Thank you for joining us on the Water Hour, the show that dives deep into the critical role of water in shaping our society and economy. Join us next time as we explore the work of the South African Water Chamber, only on the Water Hour.